on object-oriented programming versus data-oriented programming, which one to choose. My name is Venkat Subramaniam. We're going to talk about one that we are extremely familiar with and have used extensively. The other one is relatively new for a lot of us in the Java ecosystem, but we want to talk about when should we choose which. Best time to ask questions or make comments is anytime you have a question or a comment, so please don't hesitate. One of the things that I've realized over several years is we can get into a debate of which one is the right tool to use. And I feel that usually is not very productive. That's exactly the feeling I got from discussions related to object-oriented programming versus functional programming. Oftentimes people talk about, oh, you should use this and not that. And what I realized is that these are simply tools. And there are times when a tool is a right choice, and there are times when a different tool is a right choice. And oftentimes, just like out in the world, we can use multiple tools to solve a same set of problems as well. So as a result, rather than asking which is the only one we should use, I think we should really understand within a given set of problems, what problem may be suitable for, what tool may be suitable for what kind of problem. So that's what I want to focus on today in this discussion. When it comes to object-oriented programming, I think this is something we all have used very extensively. I'm going to date myself, but I remember very fondly the time when the world used to debate about OOP sucks versus OOP rocks. And I've read through so many discussions back in the 80s, and then suddenly all that noise quieted out. Not for the good, but it quieted out. And everybody got on that bandwagon of object-oriented programming. And then we stopped questioning whether OOP is the right choice. We started using it, and to a great extent, misusing it as well. And to a great extent, I would say, languages like C++ made that happen. And it converted a large number of developers towards using OOP for the right, for the good or bad, doesn't matter. But if you really think about OOP, I would say OOP contains 4 pillars, if you will. And the first pillar is, of course, abstraction. But abstraction is nothing new. We have been doing abstraction ever since we started thinking as humans. Stories of Plato talking about abstraction of things rather than the real things. So we use abstraction. So what is abstraction really? To me, abstraction is the way we humans deal with complexity. Without abstraction, we'll go crazy very quickly. So abstraction allows us to separate the essential details from things that we don't need to care about just yet. So as a result, we are able to focus at the right level of abstraction as we talk about. So that's a very important pillar of OOP, but make no mistake, that's not exclusive to OOP by any means. You have it in almost everything that we do abstraction. The next pillar of OOP, of course, is encapsulation. Encapsulation, they say, is data hiding. I beg to differ. That, I think, is very misleading. It's not data hiding, it's implementation hiding. I don't want to know. It's a separation of what we do from how we do it. And that's basically what encapsulation gives us, is the ability to focus on what we can accomplish, but the details of how it's being done is kind of hidden away from us. And the hiding really is not secretive hiding, but the hiding is you don't need to know this right now, because knowing that actually makes your life worse than just depending on the layer you need to depend on. But honestly, though, once again, I would argue, as much as encapsulation is extremely essential for object-oriented programming, it's nothing to do with OOP exclusively. We've been doing encapsulation ever since we started writing code. You define a variable within a function. Gosh, that's encapsulated within the function. Outside the function, I cannot, should not be able to reach your variable that you define within a function. So functions give you encapsulation. So do objects give you encapsulation. So do files give you encapsulation. So do modules give you encapsulation. So encapsulation exists anywhere you want it to exist. So again, I would argue that's not one of the most essential. But of course, in OOP, there's something called the weakest link. And the weakest link of OOP is inheritance. This is unfortunate because in true object-oriented programming, you really don't need inheritance. This is one of the problems. If I programmed in one language or one set of language my entire life, and some of us have, and then we come out thinking you cannot do OOP without inheritance. But as it turns out, a lot of languages that do OOP don't require inheritance at all. So you could do OOP without any inheritance. And so that, to me, that's why I call it the weakest link, because that's not essential to the fundamentals of the paradigm, though it becomes required in some languages, or many languages to be fair, that do implement OOP. So that leaves us only one thing, which turns out to be polymorphism. And to me, if you really ask, polymorphism probably is the essence of object-oriented programming in my view, because polymorphism gives us the ability to write extensible code. Now you may even argue at that point and say, gosh, you could have polymorphic code even with function pointers. Yes, but there are no survivors from that, right? So it's incredibly hard to write the code and maintain the code. So you could say OOP gives us clean polymorphism. It is where you can use it and still smile at each other after writing that code. So it becomes a lot easier to work with it. So polymorphism gives us extensibility in the code. So essentially, you don't have to rely upon the type of the class you are working with, but the runtime type of the object. So this is really where the benefit shines with OOP in general. So for example, let's say for a minute that I'm really interested in just thinking through it. Let's say I have an order class for a minute, and given this order class, let's say I have a function, let's just say, let's call it as process order, and let's just kind of ignore the order details. I'm not interested really in working with those information. Let's keep it extremely focused and simple here, pardon me. So essentially, let's say I'm really interested in here in a payment. So I say credit card, let's say, and then we'll say credit card. So I want to be able to receive a credit card and then pay for this order through a credit card. So I could really write the code, again, excluding things we don't need to care about right now. I could say a credit card.charge, and I could charge the amount for this particular payment. So ignoring all the other code, we could say, yeah, that seems reasonable. We can charge the credit card to process that order. Depending on what it returns, we can take actions and blah, blah, blah. We don't care about it. But the key thing here is we have a tight coupling between the order and the credit card right in here. So what does tight coupling mean? Tight coupling means we fail open-closed principle. Tight coupling means the code is not extensible if we decide to make a change to the system. So in order to make this more extensible, what we would typically do is we would create maybe an interface, pardon me, an interface, let's say call it as a payment, let's call it as a payment method, and the payment method probably can contain details like, for example, it could have a pay method and which takes an amount as an argument. Well, in that case, we can simply create a credit card in this case, and this could be a credit card, implements the payment method, if you will. And in this case, of course, we can implement the pay amount method to do whatever it needs to do. But likewise, you could pretty much say, hey, maybe I want, going back to this, you can say, this is going to be a payment method we are going to bring in, and we'll just simply say payment method. Well, obviously, in this case, the payment method, right? This is things that we have used quite extensively, and you can say pay, and you can provide the amount for the payment. Well, in this, of course, you could also create other forms of payment. For example, you could say, maybe I want to pay using a bank transfer. So essentially, or other forms of payment right now. And you could say this all implements payment method. And in a typical system, we might have maybe 10 different methods of payment, if you will. But what did this really provide for us? The benefit of this, of course, is that the payment order now doesn't have to be modified as long as the new payment method we introduce is conformant to this payment method interface. Now, this is the benefit you get out of polymorphism. And you could say, well, wait a minute, isn't that inheritance? Well, no, it's polymorphism that gives you this benefit. The reason polymorphism gives you this benefit is when you call the pay method, you don't care about what its type is at compile time. You care about what its type is at runtime. Now, in a statically typed language like Java and C# and C++, you rely on inheritance to be able to gain polymorphism. But if you're working on languages that are dynamically typed, like Python, for example, or JavaScript and Ruby and so on, when you don't care about this. So this brings up a really interesting way of looking at software. This actually excites me because there is actually two schools of thought here. Again, I want to emphasize neither one is right, neither one is wrong. When we take the approach of right and wrong, it becomes problematic. But which is better at any given time becomes a much richer conversation. So this difference to me is really design by contract versus design by capability. So the design by contract is, I don't care what you can do, but let me check your contract. Are you this type, then you can come in, otherwise stay out. Well, that is design by contract. Surely there's benefits to it because you can verify things at compile time, and that becomes very useful. Design by capability is, I don't care about what type this is, but as long as I can fulfill my request at runtime, that's compatible for me. So generally speaking, your statically typed languages provide design by contract, dynamically typed languages provide design by capability. So when I program between these two different languages, when I program in Java, for example, I rely a lot more on design by contract. When I program in Python, for example, I rely more on design by capability, and that's just a different set of mindset and tool I can bring them in. But in both cases, what I'm leveraging is polymorphism because the latter doesn't care about inheritance after all, but the former actually does because of the limitations, in my opinion, rather than the power in that case. So that is OOP. And I'm going to say OOP is a fantastic tool. I am not going to say OOP is bad because it has given us benefit, it's given us value, and I think it's super useful. I actually use OOP with functional programming as an example, so I believe in really making use of these tools for the right purpose. Having said that though, there are times when one particular design, one particular approach that may give you a really good result may not be the right choice when things don't work in your favor. And I think this is where not being really tied to these ideas emotionally can help us to distance ourselves from the tool and be able to use the right tool to solve our problem. I often say this about languages and design options is, I don't want to be a programmer of a certain type. I want to be a problem solver. So when I'm a problem solver, I look for tools that help me to solve my problem. But if I'm attached to a particular solution, then I'm looking for problems to use that solution, which is very dangerous in general. So essentially, I would say, well, this is a great idea here, but is it a good idea over here? So let's look at a slightly different concern, if you will, to shift our emphasis or the focus right now in this particular case. So we looked at the benefits of OOP. I'm speaking to the choir here because you know this, you have used it extensively, but that was a good refresher in our mind what it actually provides for us. So we can definitely leverage OOP to do what we do. But let's shift our focus just a little bit, if you will, like I mentioned. So imagine for a minute that I have a third-party class that I'm working with. So just for our sake, imagine this is coming from a jar file. I don't have a source code for it. So, but of course, I want to be able to see it, so I'm going to simulate it here. But imagine this is a third party. What does it mean by third party? I don't have the ability to modify this code. I'm not going to sit down and change the code or enhance the hierarchy. And this is something we do quite often. We use libraries of code, and the library provides a set of classes for us to be able to use in our applications. This could be a third party, as in a completely different company that provides this for you. It could be a third party, as in another team in your enterprise maintains that code, and you cannot modify it. Or even within your own team, you may have a large application, but that's not the area of code that you are entitled to modify, but you are able to use that though. So these are the third-party codes. So I have a little interface called the trade interface, as you can see in here. So similarly, I have a cell class, which implements the trade, and all that it contains is a final field. I could have written a getter and setter around it, but that's not going to give me any value in this discussion. So intentionally, I did not write a getter and setter. Similarly, we have a buy, which implements the trade as well. So essentially, I have a sell and a buy, both of which are implementing trade. Again, imagine all those three things come from the third-party library, if you will. So given this, I want to be able to use this in my own code. So from the OOP point of view, I'm going to say a process trade, and this is going to be a new cell method. And let's go ahead and say this is going to be a Google of 2000. And I'm going to also say a process, let's say trade, and I'm going to say new buy, and that's going to be, let's say, AMZN, and I'm going to buy, let's say, 1,000 shares of AMZN right now. Well, okay, so far so good. I've got those imported in my code, but what does the process trade actually do? Again, without complicating things too much, let's say we have a trade, and that's going to be the trade that I'm going to be bringing in, but I want to perform some trade on that particular trade, right? I'm going to perform a transaction on the trade. But how do I perform this trade transaction? Just to make things a little bit more interesting here, let's go ahead and say that I've decided to use, let's say, some form of AOP, let's say. So essentially, in this case, I'm just going to turn that into a star. My IDE is refusing to work with me right now. Okay, so all I want to do is assume we are going to use AOP to, let's say, inject, let's say in this case, inject, let's say, an interceptor that, let's say, performs some audit. So your company says, hey, we're going to be performing trade, but we got, the requirement, we do auditing on the trade. We don't want programmers to be messing with it. Let's do an AOP injection. I'm not going to use AOP here, but I'm going to just simulate that in our mind. So what I'm going to do here is to say interceptor. Well, I need an interceptor, so I'm going to say interceptor is equal to, and I need to be able to get an interceptor, so we'll get to that in a minute. And then I'm going to say interceptor dot, let's say, audit. So I'm going to do an audit on it and pass the trade for me to audit it. Once the interception is over, we could continue do whatever else, right, that you can continue doing your processing. So the question here is, how do we implement this particular interceptor? So let's go ahead and create an interface called interceptor that's on my client side. And the interceptor basically says, I'm going to be an interface right there. So this is going to be an audit function that takes a trade, and I'm going to pass a trade to it. In fact, let's even return a Boolean here just for this example. So once I audit, I can return back a trade, a Boolean for a true or a false, depending on whether the audit succeeded or it didn't. So given this, of course, we want to be able to write our code for performing the auditing. Now, with an object-oriented mindset, I could say, no worries, I can now implement readily another class in here. This is going to be a cell interceptor, right? So cell interceptor, and what does the cell interceptor do? Well, the cell interceptor implements the interceptor, and as a result, I'm going to implement the audit function, and we can sing the tunes of OOP right now and say, that's inheritance and polymorphism we are using. Very similar to the code we wrote a few minutes ago for the payment method, isn't it? So what I can do here is, let's assume that this goes through for a minute in this little example, but I can say, oh, by the way, this is for a cell. So what are we going to do? I'm going to say, first of all, we could say if the trade is an instance of a cell, then I want to do the rest of the work. And then I can say, well, it's a cell, so might as well use more recent features in Java, and we could simply use the pattern matching with instance of and provide the cell right there. Then I can say if the cell.quantity is greater than, let's say 1,000, we can provide a little bit of a detail, right? Well, first of all, this could be simply saying auditing, let's say cell, auditing, there we go, a cell, and then I could print out, selling large volume. So maybe I really need to know that a large volume is being sent because there's a regulation maybe that says monitor large volume of sales, I got to handle it. But look at what's going to happen right away. This is great so far, but what if it is not, right? Well, if it's not a cell, I shouldn't just ignore it, right? So I could say throw potentially, and I could say new, maybe an exception of some sort, whatever exception you decide, and we could say, unrecognized, we could say a sale. So a trade rather. Well, you're not supposed to have sent this to me, and you did it. Okay, so that's not too bad, right? And that's how design goes bad when we say it's not too bad. So this is also called the Stockholm syndrome, right? We keep using it, yeah, but they were not really that bad. They kept feeding us every day. So we kind of get dragged into messy code, and then we live with it. I absolutely love the metaphor of code smell. Ken Beck coined this term. I love this idea. He used the word code smell. And I apologize for my analogy. So I'm a big fan of gross analogies, because when you give gross analogy, people never forget the analogy. So here is my analysis about it. I love code smell because I often say code smell is like body odor. You sense others quickly than your own. So when I write code, this is good. When somebody else writes the same code, I'm like, wow, what smelly it is. But that's also a problem because you are sitting in a room and somebody walks in, they twitch their nose and say, what's that funny smell? And you say, what do you mean funny smell? I've been here for 20 minutes, I don't smell anything. That's the problem. When you have a really, really crappy code, if you live with it, it becomes a pattern instead of a smell. And this is one of the reasons why we got to recognize it quickly and refactor it. Otherwise, it just becomes, this is how we do a code around here. So this is the code we wrote. Again, this is not my complaint about OOP by any stretch of imagination, right? I already mentioned I love it. It's great to use. But here is an example where I had to do this work. But what's going to be a problem in this particular case? Well, I'm going to just grab this code for a minute. We'll come back to this. And I'm going to go back here and provide one more. And this is going to be the buy interceptor, as you would expect. And what does a buy interceptor do? It implements, in this case, the interceptor again. And as a result, you would expect it has the method for the audit as well. And what does the audit do? It says if it's a buy, and I'm going to bring in the buy, and what am I going to do with the buy? Well, if the buy quantity maybe is more than 10,000, maybe it's a buying large volume, whatever the business rules are, and again an unrecognized trade. So right off the bat, one of the problems you see already is this part becomes a little bit smelly. This is not dry. You have to do this in every part to say that if it's what I know, I will handle it. If it's not, I want to reject it. So that's a minor problem, a little duplication of code. You may argue, well, dude, if you really take this and abstract it to a base class, then you can eliminate that duplication. The derive can do the work it does, and if it cannot handle it, the base can reject it. I absolutely agree with you. So in a sense, we can refactor this to remove the duplication, That's perfectly fine, but we got to recognize and work on that. So now that we did that, what are we going to do here? Well, in this case, of course, I need to get the interceptor. Now, how do I get to the interceptor? Well, there are a couple of different options available to me, right? I can use an if-else statement. As long as I don't display that in public, that's okay. But it's going to get really messy, not something you'll be proud about. You could potentially use reflection to do that as well. So for example, you could say, in this case, a string. This could be a trade class name is equal to trade.getClass.getName. So you got the name of the, get a simple name maybe, we'll do that. Then we can say this is going to be a class.forName, and then we can provide the trade class name. We can get the declared constructor from it. So once we get the declared constructor, we could do a new instance on that constructor and create an object in this case, and that object is going to be an interceptor implementation essentially. Well, the minute we do that, as you can see, Java says, hey, you need to handle exception. Now, as experienced programmers, we know exactly how to take care of it, right? So we can simply say, throws exception, I don't need to deal with that right now, right? So again, I'm just kidding, but only a little bit. So essentially, in this case, we just say, throw that away, I don't need to care about it right now. I would argue this is called the accidental complexity. One of the things I love in what we do, I was working on a piece of code yesterday, and I was just chuckling, and my wife looked at me and said, what's so funny about what you're doing? And I said, I'm actually working on code that had nothing to do with the problem I was solving. And I suddenly got dragged into this code now. I got to solve this problem before I can solve my real problem. We often get into this thing called yak shaving in our industry. You forget why you started doing this problem, because something led to something else, and now you're trying to figure out how to solve that problem. It distracts you from the real thing. This is an accidental complexity. Dealing with that exception is not part of your domain-related problem. Why are we dealing with exception? Because this library tells me I have to deal with it, right? So that's another complexity we are dealing with. This is often a self-inflicted wound we drag in to do this. And of course, you could have written the code to throw the proper exception. You should, but that's what we are doing here. So we got that particular code to work in there to call that. But of course, this is not going to be stopping so easily. It's relentless. That really populates to the other function as well now. And then you got to go fix that over there, handle it properly, whatever you need to do. So now that we wrote that code, what are we going to do in here? So in this particular case, obviously, well, we need to make sure we are dealing with this properly. I didn't really handle it properly yet. So we want to create the class, but what is it going to be? So this is going to be the trade class name, but what I really want to use here is going to be, this is going to be a client dot, and then of course the trade class name plus is going to be the interceptor that I really want to use as the name in this case to use the object. Whew, that actually ran. It gave us some audit sell, selling large volume, audit buy, copy and paste error. So essentially the idea is that, so that's a buy, right? Cool. So we got that working, but the question I want to ask is, at what cost? So essentially when we finished this, what we ended up doing in this particular case is, we created a parallel hierarchy that corresponds to the trade in this case. So you have a trade, you have an interceptor. Okay, maybe I should have called it as trade interceptor. That would have been really clear, right? So you have a trade, you have a trade interceptor. You have sell, you have a sell interceptor. You have a buy, you have a buy interceptor. Now, let's say things evolve after a while, and you now have, let's say, a new class in the third party. Let's call this one as hedge for no good reason. And this actually implements, let's say, a trade. So in this case, of course, this is going to have some data in it. I don't care about the data right now. So that's my new thing that I added. Well, the very first problem is, in this particular code, there is no indication that you potentially have a problem. So the compiler is not helping you at this point. Again, don't get me wrong. In languages that provide compiler, I want to exploit it. I want to get the maximum benefit from a compiler. So I introduced a new abstraction in my system my compiler doesn't tell me anything about it, right? It doesn't say, ooh, maybe you should handle it, you're not handling it. That's one problem. The second problem is, if I were to go back here in this code, and if I were to say a process trade, new hedge, I introduce a new one here, no compilation error, but it results in a runtime error. So once again, I think most of us will agree that it's better to get a compile time error than a runtime error where it's possible. Well, in this case, of course, it doesn't give us a compile time error. The next thing, of course, is I've got to implement now a parallel class, the hedge interceptor in this particular case. But once I implement it, then, of course, I can be sure that my code is handling it. But everywhere that needs to be handled, I got to make sure it's being handled, because a compiler, again, is not going to help me. So the moral of the story here is, OOP is great, but what really becomes a problem is we end up building this parallel hierarchy. Now, let me just be absolutely blunt about it. I am a big fan of simple solutions that work. Now, anytime somebody comes to me and says, what design pattern can I use? To me, that's usually a problem, not a solution. Because I once tweeted, I said, no programmer ever uses the following words in their deathbed. I wish I had used more design pattern, right? So I often tell people, when you wake up in the morning, if the first question on your mind is, I wonder what pattern I can use at work today, I recommend calling the boss and saying you're very sick and you don't want to come to work that day, right? So the reason I say that is, somebody would come to you and say, ooh, this is like a visitor pattern. I honestly will tell you, the number of times I've benefited from visitor pattern is very close to zero. And the reason is not that it's not a nice pattern. It is very complicated for most of the solutions in my applications. I literally had a developer walk into my office and said, I'm trying to use visitor pattern. I'm having a really hard time. Can you please help me? I'm like, of course. And we started talking about the problem this person is solving. We spent about 10 minutes talking about it. We went to the board, drew a little diagram, and we said, here's a way we can solve it. We talked about it. He made a few suggestions. And then I said, so there you go. That's going to solve your problem. He's like, wow, it's actually that simple. I could get this done in the next 15 to 30 minutes. Thank you. And then he steps out, turns around and says, wait a minute. I came to you asking how to use visitor pattern, and you never bothered to answer that question. And I said, what's your goal? Is your goal to solve the problem, or is your goal to use the visitor pattern? He kind of chuckled and said, I guess I know the answer now. Thank you for the help. And he walked away. So again, if visitor pattern is the right solution for what you do, that's great. But I often say, I discover the use of patterns rather than force fit a pattern. And when I look at a solution, I say, oh, look at what we did. We looked like we used a pattern here. Well, that's great, but I don't want to sit there and say, I can solve this code using this pattern. In fact, in this particular case, if that's all I chose to do, the net result is a complicated code, in my opinion. So what can we do differently? So this is where I say, when classes can become clumsy, and they do occasionally in our systems, and this is the example we saw, is processing of the third-party data. What can we do to minimize these troubles? So a little bit of a different way to implement it. But before we go that route, I want you to think about something a little bit different. This is where it really becomes a problem in what we do. So the first thing I would say is design principles are really good, really useful, but do not follow, I would say, principles for the sake of, I would say, following principles. This is one of the things that is really hard, because people can get angry and say, what do you mean? These are really good principles. You should be following it. But to me, there are times when principles are useful, and there are times when principles may not be that much help. And so one of the real important things for us to keep in mind is, design, I would say, and architecture is really about evaluating trade-offs. So this is one of the things we have to keep in mind. We are not choosing solutions. What we are doing is we are figuring out the compromises between solutions. This is a good idea here, but it's not a good idea here. It's like the difference between being comfortable, as an example, and saving money. There are times I want to save money, so I may be a little bit more uncomfortable at that time. There are other times when I want to be more comfortable. I don't mind paying a little bit more for that comfort. But it's not one or the other all the time. I choose based on the situation. And I say, here it makes sense to do this trade-off. Here it makes sense to tilt the other way. And we want to really be able to make that shift in our mind. So one principle we all have really been honoring quite a bit is this wonderful principle called open-closed principle. And if you really ask me, and you ask people that know me and worked with me, they will tell you, oh my gosh, you want to make Venkat angry, violate open-closed principle in front of him, right? Because I do value this principle. I want to write extensible code. So absolutely, if you're able to give me extensibility, I'm like, this is cool. Look how I can drop this in the part of the system. I don't have to change that part. That is a great idea, but there's a cost associated with it. And the question you want to ask is, are we better off with that compromise, or are we better off without that compromise? And there is no clear answer to it all the time. You could say, well, in this situation, this is better. In that situation, that's not better. I'll give you one example of that. When you generally talk about things, you often say, we need to follow dry principle. Well, if I ask you, should I duplicate code? You're like, oh my gosh, I cannot believe you asked that question. Heck no, you shouldn't duplicate code. Can I duplicate anything? You say, oh my gosh, no. Duplication is bad, don't do it. Well, that's a nice advice in general, absolutely. Now I can ask you, should I increase coupling or should I reduce coupling? And you're going to be like, gosh, of course you want to reduce coupling. But if you really take two sentences together that remove duplication and lower coupling, we absolutely contradicted ourselves. Because if you want to reduce duplication, you got to create something you can depend on, and by nature, you're increasing coupling. So in a monolith, I often will reduce duplication because coupling is a natural part of life in a monolith. But when I'm creating a microservice, I want to reduce coupling because when it comes to a microservice, I want one part of the system to evolve independent of another part of the system. So if I reduce coupling, it gives me that agility. So in the case of a microservice, I do an intentional duplication, but not because I feel good about duplicating. I'm duplicating because by duplicating, I'm respectfully lowering coupling and improving my agility in my system. So this is where the trade-off really come in. So when you look at a solution, you could say, oh my gosh, that's not extensible. Well, I get it. But this is intentionally not extensible because we reduce the complexity overall, and it's a cost we're going to spend, but that cost is minimum compared to otherwise what we'll incur to provide that level of extensibility. So the key here is to keep in mind that you are evaluating trade-off. You are not looking for a perfect solution. You know why? Because that doesn't exist. So a perfect solution doesn't exist because when you come up with one solution, you're going to find pros and cons. When you look at another solution, you're going to find pros and cons there as well. So now you're asking the question, which one of them is the least worst, right? And which one is going to cost me the least in the long term? Which one is simpler than the other? That's the kind of question you are asking in general. So given that in here, let's see what we can do with this particular solution. So I go back to this code. I'm going to get rid of the hedge for just a little bit. We can always come back and create it later, and we can work with it. So remove that. So then I'm going to simply say, in this particular case, I'm going to simply say, hey, I'm going to go back to this interceptor, pardon me, and in the interceptor, I'm going to just keep it as an interface for now, or you can create it as a class depending on what you want to do, but let's just keep it as an interface just for a minute. So I'm going to say a static Boolean audit, and I'm going to say trade, and I'm going to implement that here as a static method. So I'm going to simply say return true for now. Again, we're not so keenly interested in the logic. So then what I'm going to do here is to go into the cell interceptor, and I'm going to grab this code right here for a minute. Let's just copy that over. Let's bring it back here. And I'm going to say, here is my trade function. If the trade is a cell, I want to perform that operation. Great. And then, of course, I can simply say here, return true. Again, we'll come back and fix this in a few minutes. Then I'm going to say, go to the by interceptor. I'm going to throw away the cell. I don't care about it right now. Then I'm going to go to the by interceptor, copy that code again for a minute, and then I'm going to simply take this part right here. And once again, let's get rid of the by interceptor. We don't care about it. And then I'm going to simply say, if the trade is a buy, then do that work for me. And of course, if it's successful, simply return, in this case, let's say return a true as well. If not, I can simply say in here, we could say, throw, let's say, new runtime exception, invalid, unrecognized, let's say, recognized trade. We'll again come back and look at it in a few minutes. So we have not made it fully good, but we are heading in that direction, right? So that's basically what we're going to do here. So if I go back to the code, the first thing that happens here is that I don't need to do that stuff anymore. So we can go back directly and say, hey, interceptor, simply do the audit for me in this particular case, right? So we can ask the interceptor to perform the audit right there, and all that complex code that we used, we could celebrate it as using the factory method pattern or abstract factory. But this is one of the other things I often say. The more we celebrate patterns is a sign of poor design, rather than being a really good design. When a language is powerful, we often talk less about patterns. When a language is not very powerful, we employ more patterns. So we did use patterns right there, but we don't need to do it when we can take different options. When the language becomes more powerful, we can ease on the patterns, if you will. So back here, I'm going to go back and run the code. It worked, produced the same result, but what's the difference? The difference is we got rid of those two extra classes, right? Now, we can go a little further with this. You can then say, all right, that's fine, but back in the audit, I can simply say return a switch statement, and in this case, I could say, if this is the trade you are receiving, I'm going to say this is going to be a case where we are using a cell, and we'll call it as a cell, so the rest of this code is going to be almost the same. So I'm going to say, go ahead and print that out, evaluate that for me, and when you're done, go ahead and return the true from this particular call, right? So we can yield a true as a result from this particular call. So we can say, I want to return a true after this processing of that particular code. Similarly, you could then say, all right, that's my case for the cell. Here's a case for my buy at this point. And what do I do with the buy? Once again, we can simply say, this is going to be the pattern matching syntax. Go ahead and process that for me. If that was successful, yield a true for me in this case. And when you're done, what if it is not any one of them? Oh, if it is not any one of them, let's notice, first of all, the compiler is telling us something. It is telling us that the switch is, well, in this case, it says it's always true, but it's going to tell you that you're not handling all possibilities, right? So I'm going to say throw, let's say in this case, new runtime exception, maybe unrecognized, recognized trade. So we could write that code right there and return the response back to the caller. So this could be the code we are writing. We'll come back to this in a few minutes once we know that this is actually working. So that seems to be fine. But I go back to this interceptor, what did we just do? Now, clearly in this case, you don't have to make the code long and ugly. You could have written private methods. Interfaces do have private methods. You can put them in classes too and call those private methods. So it becomes a nice way of handle, sell, handle by, so you can clean up the code, make it pretty and easier to understand. That is called SLAP, single level of abstraction principle. I'm a huge fan of SLAP, not a physical one, but in code. So a SLAP actually makes the code easier to understand, easier to maintain, so we could use the SLAP in here. So to use the SLAP, all you have to do here is to simply use the extract method refactoring. So if you go to refactor, you say extract method, and you could say handle, let's say handle cell, and you could just call the handle cell method and ask it to provide that, for example, right? So essentially, you could do the handle cell, and similarly here, you could do the handle by method as well, but you get the point. So two different methods to do the job, and that'll do the job really well. So you could do that refactoring. But going back to this for a minute, if you were to remove this default from here, what's going to happen in this particular code when you remove the default? Well, it says switch expression does not cover all possible values. That's the first benefit you are getting, that it's not covering all possible values. Now, the obvious answer is, well, duh, go put your default in there. But I beg to differ. If you put a default, you are providing an implementation for what's not being handled. But the minute you provide default, keep in your mind, you are asking for a runtime solution, not a compile time solution. That's the way I look at a default. Default means, let me handle this at runtime. But we talked about this. There's benefit to handling things at compile time. So we're going to take a slightly different approach in here. We're going to go back to the trade. Again, remember, you can convince your third party to grow up and implement newer versions, right? When it makes sense, we can simply say, hey, this is going to be a sealed interface called trade, and the trade will permit, in this particular case, a sell and a buy as the two things that are permitted. So then if I go to the sell, I'm going to say this is the final class called sell, and while we are at it, let's simply change it to a record in this case because it makes life really easy. And I can say string ticker and int quantity, and then of course I can get rid of all that extra boilerplated code, and that becomes a record of sell which implements the trade sealed interface. Likewise, I can go to the buy, and I can say the buy is also a record is already final, so I don't need to say final. That's really another beauty of records, right? Records are final. You don't have to say final record, right? So that's no reason to do that. So that's your record. So it's automatically final for you. Similarly, I go to the buy, and I say it's a record, and this record again is a string, a ticker, and I'm going to say quantity again. And this time, let's get rid of all that extra code. So we made that a record and made the base a sealed interface. The benefit of doing so is that because trade is an interface and it's a sealed, the compiler is going to be smarter at this in this particular case. So what are we going to do? So obviously, in this case, if nothing is handled, you need to return a response, but it's complaining that it's true all the time, but we'll worry about this later. So I'm going to say this is the quantity I'm interested in because it's a record. We're going to change it. I'm going to just change it to a false just for a minute, not because it's relevant. I just want to shut up the IDE from saying that to me. So essentially, in this case, you can see we implemented this code using the switch, but we did not implement the default in this case. If I go back to the code and execute it, that still works. But the question is, what's going to happen when the third party evolves? So here is a class again. We'll make it a record also again. Can be a class if you want it to be, doesn't matter. So in this case, I say here's a ticker, and it's going to be a quantity as well. And then I say in here implements the trade. So when I implement the trade, what is it going to do? So now that we implemented the trade interface in this case, it says it's not allowed to seal because I've not given the permission for it. So let's go ahead and do a permit on that. So this is going to be a hedge. So we added those two, but if you go back to the interceptor, in this particular case, you can see it's giving us an error already. It says switch expression does not cover all possible input value. So if I were to try to compile this code right now, you will notice that I should get a compilation error, right? That's the whole idea, is to tell me that this is not being handled, and it should tell us that, hey, your interceptor is not valid at this point. I'm not sure why that actually didn't give us an error. It's probably just not synchronized properly, more of an ID problem, I think. But this says over here, right, switch expression does not cover all possible input. One thing I've learned with IDEs in general is it works great when you reboot. So I'm going to just do that for a second. So just restart the IDE one more time. My editor is misbehaving. Let me try this one more time. Okay, there we go. So let's just open it again, see if it gives us an error and says that I cannot run the code. If it doesn't, I'll keep moving. It should. So that's basically the idea. Okay, something is weird here. Anyway, so interceptor is giving us an error right there. Switch expression does not cover all possible input values, which is what you want, right? You want to have this as a compile error, and it gives you that error. Now, obviously, one more question. What if this is a third-party code? They evolved it, but I didn't recompile my code. What's going to happen? Well, that's one of the nice things about switch is when you don't write a default, they write one for you automatically. So at runtime, it will tell you that this case is not being handled. So the worst case scenario is still no worse than what you would have done otherwise. But the best case scenario is you do get a compilation error that tells you that you're not handling a particular situation. So, but what did we gain? What did we lose? Remember, it's all about trade-off. It's not about a perfect solution, right? So what did we gain? What did we lose? The first thing we gained, honestly, is when you look at this code, if I were to rework this code, you're going to see something along the lines of a process, let's say handle, you could say handle a cell, right? And you're going to pass the cell to it. Similarly, for the buy, just to clean up the code to make it more meaningful, you would have done something along the lines of handle, let's say, buy, right? And you pass the buy to it. So when you look at the code like this becomes a lot cleaner in terms of the code that you have in here. And when you look at this code, you're like, okay, I get it, what we are doing. So, of course, if you have a newer case, what you're going to then do is to say a case hedge, and you could then say, I want to handle the hedge, so you could pretty much write that code and provide that particular function. So the benefit of this is what I mentioned about as slap earlier. Your code is a lot cleaner to write, but the biggest benefit at this point, in my opinion, is I can actually sit down and talk to my domain experts. So when they ask me, how is this handled, I can actually show them the code and not an UML diagram, right? I can say, look, that's what we're doing in the code. And they're like, oh, okay, so these are the things we are handling, and we can talk them about business logic by looking at the code. So the code matches closely with the domain expectations. I'm a big fan when the code resembles the business logic, right? The business expectations. So you're not saying, you don't worry about it. We are doing OOP. We got mapped this into this hierarchy of objects, and their head is spinning. Why do you need all of that to get this work done? And we say, you don't understand extensibility, right? So we don't have to deal with that. It becomes very easy to explain what the code is doing. What are we doing literally? We are handling the data, right? Records are data, that's what they are. It's not a behavior on that other end. But of course, you have a different set of actions for that behavior. That's fair enough, but you don't benefit from the object hierarchy in this case. Oh, but wait a minute, but the code is not extensible. Well, I will completely agree with you on that. But this is a forced choice I'm making right now. So the trade-off here is I could have written a new class that can implement the logic for the hedge, or another new class when a new type is added. But the first problem is I won't get a compilation error. I got to remember that. Second, I got to do more testing. Don't get me wrong. I'm a big fan of testing. But when a compiler can do the work for me, that means I have to depend less on test. It brings the error forefront to compilation time than to runtime. It also becomes easier to change the code. When I have to make a change to the code, I write one function, I'm done. I don't have to write a class and implement a method and do all of that because I don't care for that object hierarchy at this point. And another benefit is I truly believe the design is simpler and cleaner than the object hierarchy. So what should we do? When should we use which? So my recommendation is use object-oriented programming when you truly benefit from polymorphism. But if polymorphism gives you not as much benefit in comparison to the clutter in the code and the hierarchy you had to create, then I would say we are willfully making a trade-off right now. Rather than building an object hierarchy, because there is not as much benefit, we are going to cut down on that, and we're going to bring this down really to something simpler. Sure, there's a trade-off. When we add something new, we cannot just throw in a class and walk away, but instead of adding a class, you're going to make a small change. You're adding a function and then routing to that function in your code. So that's not too bad after all. It's a little bit of an effort, but you got the compiler benefit, you got a simpler code, easier to understand, easier to maintain, easier to resend the code, easier to explain to your business, and easier to work with it in general. So to me, it's not this or that. And I would say use what makes sense. And to me, OOP makes really good sense when I really need to build for extensibility. Like in the example we saw, where I want to include the code for processing the payment methods. That's my hierarchy of classes I maintain. So if it's my hierarchy of classes, I'm a bit more inclined to do OOP. But if I'm relying on a third-party class, and if I'm building a parallel hierarchy, I would ask the question, are we benefiting from this, or is it more of a clutter and noise that we can reduce by not really relying upon the OOP ideas, but maybe relying upon data-oriented programming? Hope that was useful. Thank you for attending.